Good morning, class. We are looking at the law of cosine, section 8.2. This is application of trigonometric functions. So we did look at the law of sines. Now we're going to look at the law of cosines. And we will continue to polar equations afterwards. The objectives, we're going to solve SAS, side, angle, side. We're going to solve side, 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 and applied problems. So those are the type of triangles. We've seen many different formulas, basic trig identities. And then we added the sine law, and now we are adding the cosine law. I'm going to discuss that with more details in a moment. The sum, difference, double angle, half angle, you name it. The right triangle and the relationship between sides and trigonometric functions. Angle of elevation versus angle of depression. Bearing, there are a couple of different methods we will look at it. And then when we looked at the law of sines, we did look at various cases of triangular shapes where we want to solve them. And I went over the details of that. And so in short, we have ASA angle, side angle, angle. And that gives us one side with two angles, which has a unique solution. We have SSA, which has side angle, two sides and an angle. Opposite one of them, which is known as an ambiguous case. And now we're going to get to SAS, side angle, side, that has a unique solution. And all sides SSS, as long as no side is larger or equal than the sum of the other two sides. So here's the law of cosine. A squared equals B squared plus C squared minus 2BC cosine A. And cosine A is A, the included angle. We're going to go over that in a moment. So when we get to case 3, side angle, side, two sides and the included angle. That's what when we use the cosine law, and it results in precisely one unique solution. The last case, when we have all sides, we have three sides. This results in one unique solution and one unique triangle, as long as one side is smaller than the sum of the other two sides and does require the sine. So the theorem is that if you have a side, it has no solutions if one side is larger or equal to the sum of the other two sides. So one side is larger than or equal to the sum of the other two sides. And A squared is B squared plus C squared minus 2BC cosine. And notice the notation if you are solving for A, for example. Lowercase ABC represent the sides, uppercase ABC represent the angles. And so lowercase a is opposite angle A, lowercase b opposite angle B, lowercase c opposite angle C. That's how it works. And so when A is B squared plus C squared minus 2BC cosine A, I can move this to the right and move A squared. I can move this to the left and A squared to the right. Becomes B squared plus C squared minus A squared. And I can find cosine A, which is B squared plus C squared minus A squared over 2BC. This is a way to find cosine A. You can always just use this formula to get there, or you can memorize this formula. Either way is fine. And here's the interesting part. The law of cosines generalizes the Pythagorean theorem, which holds only for right triangles. And what it's referring to is the following, everybody. So if you look at, for example, this one, c squared is a squared plus b squared. As you know, Pythagorean theorem says a squared plus b squared is c squared. If you look at this formula, cosine c, because this angle is 90 degrees, its cosine is 0, so this goes to 0, so that works out. So this is a generalized form, which means this works for any angle. And when it's 90 degrees, it's a special case of a cosine law. That's the concept, everybody. All right. Let's quickly look at the proof of this. So we have any triangle, we drop a perpendicular. This is a 90-degree angle, and it comes up with two triangles. One of them is ADC, and one of them is BDC. So we look at each case. Each one is a right triangle. So this one, for example, if you look at this one, we can write Pythagorean theorem. The sides are this one, AD squared plus H squared is AC squared. AD is X, CD is H, AC is B. So X squared plus H squared is B squared. So first and foremost, this side is X. This makes it C minus X because from A to B, opposite the capital C is lowercase c. And so we have this one. If you want, again, you can write, maybe I write that. You can write AD squared plus CD squared equals AC squared. Also, if you look at this angle, cosine is the adjacent AD or X over the hypotenuse AC or B. And therefore, we can do the cross product X becomes B times cosine A. Cross product B times cosine A. I can make up a fraction with denominator 1A. Now, let's use a different color. If we use the right side, the triangle BDC, and we can write Pythagorean theorem for that. BD squared, one side, plus CD squared, another side, equals BC squared, the hypotenuse squared. So what is BD? C minus X, that's quantity squared. What is CD? H squared. What is BC? A squared. So we write that. Now we can square this into c squared minus 2cx plus x squared, and we write the rest of them. So let's square this one. Well, we've already done some calculations. Let's put them together. X squared and h squared, we can replace it with b squared. The x, we can replace it with b cosine a. So this x, we are going to replace it with b cosine a. The sum of x squared and h squared, we're going to replace it with b squared. Let's do that. So again, the x is replaced by b cosine a, and the sum of x squared and h squared is replaced by b squared, and that simply gives us the sine law, a cosine law. A squared is b squared plus c squared minus 2bc cosine a. That's how we prove it. Again, this is one way to prove it. There are always other methods. You may have been even exposed to them, but that's one way to do that. Now we want to use cosine law to solve SAS. And by the way, if they ask you to solve a triangle, you can do it by any method. And sometimes you can mix and match the sine law, the cosine law, you name it. So let's see what is given. So capital C, this is capital C and it's 60 degrees. Lowercase a is a 2. Lowercase b is 3. And capital B, capital A, lowercase c are missing. So let's see what we can do. And we have put the formulas here in general. So as you can see, these sides, A and B are given and the included angle. So we can use c squared is a squared plus b squared minus 2ab cosine c. So we're going to use that formula. Remember, there are 3 formulas. As long as you have one, you can extend it to the others. And we're going to replace the A, B, and capital C. So obviously, this is a 4, this is 9. Cosine of 60 is 1/2. And the product of 2 and 2 and 3 is 12, with 1/2 becomes 6. 4 plus 9 minus 6 is 7. Therefore, C is the square root of 7, because this is C squared. So we found the lowercase c to be square root of 7. Now we can, since we have expanded and we have used this, we can use this formula to find the missing A. Cosine A is b squared plus c squared minus a squared over 2bc. Although at this point you can use the sine law, okay? And if they ask you to solve it, you can use the sine law. But specifically, when you continue with cosine law, so we plug into this formula, b squared. By the way, this was b squared, 3 squared over 9. C squared, this was c squared over 7, minus a squared and a squared, 2 squared over 4, over 2 times B, which is 3, times C, which is square root of 7. So we just plug in. And as you can see, 9 plus 7 minus 4 is 12. This is 6 square root of 7. Two over square root of 7. I can multiply the top and the bottom by square root of 7 to rationalize. 2 square root of 7 over 7 is cosine A. So what is A? It's cosine inverse of that. You need to use a calculator. So cosine inverse of this value becomes A. Using a calculator, we end up with 40.9. At each step, you really have to use a calculator if you have to come up with the answer. And so we have A, 40.9. So the last one is B. So add these two, subtract it from 180. So the last one is B, which is 79.1 degrees. Again, we wanted just to use the cosine law. We want to solve this. Lowercase a is a 4. Lowercase b is 3. And lowercase c is 6. In other words, all sides are given. All angles are missing. And the very first step, you must use cosine law. You have no choice. After that, you have a lot of choices. You can do either way. So let's use, since we have this formula, since we've already worked it out, let's use this formula. So cosine A is B squared plus C squared minus A squared over 2BC. And we replace the B with 3, C with 6, A with 4. The same thing for the denominator, 2BC. And we do the math. Nine plus 36 minus okay, so we can add up 9 and 36 minus 16. 29, the denominator is 36. So A is cosine inverse of this number. Cosine inverse of this number requires a calculator, and it gives us the answer 36.3 degrees. So A is 36.3 degrees. So we got this, and that's it. Now, as I mentioned, you can use the sine law if you want, but it doesn't matter. We continue with the cosine law, and we write the same formula for cosine B. In this case, we would write cosine B is A squared plus C squared minus B squared over 2AC. We replace the A and B and C accordingly from here. 43 over 48. This is obviously 16 plus 36 minus 9. 2 times 4 times 6, 48. So B is cosine inverse of this. Using a calculator, we get 26.4 degrees. That would be B. So B is 26.4 degrees. And C, the fastest way would be obviously add them up, subtract from 180. So we add up and we subtract from 180, and that is C equals 117.3 degrees. Even if they ask you to use the cosine law, they don't expect you to do this last one by cosine law. All right, a couple of applied problems. Could somebody read this, please? Go ahead, class. Could somebody read this, please? Anyone? Wow. Thanks. Nobody. Fascinating.
A boat leaves Naples for Key West 150 miles away at 15 miles per hour. It encounters heavy crosswinds and strong currents. The crew finds after 4 hours that the sailboat is off course by 20 degrees. How far is the sailboat from Key West at this time?
Thank you so much. So we are moving in this direction, supposedly. A crosswind takes us in a different direction, which is makes it 20 degrees off. And after going for 4 hours, that means 4 times 15 miles per hour. That means after going 60 miles, we have covered a distance of 60 miles. We are somewhere here, and we want to know the distance, which we are going to look for x, side x. So if you look at this triangle, we have this side, which is 60. We have this side, the distance from Naples to Key West of 150 miles. We have the included angle of 20 degrees. So across from the 20 degrees is what we are looking for, the distance of x. So we use the cosine law. A squared is b squared plus c squared minus 2bc cosine a. So in this case, a, we would say x squared equals, look at the sides. One of them is 150 squared, one of them is 60 squared, minus 2 times, multiply the two numbers, 150 and 60, and then cosine of the included angle, which is 20 degrees. So I hope you see from here we can get to here. And all you have to do now, at this point, use a calculator. Square this, multiply these numbers, find cosine of 20. Everything you put into a calculator at this point. And it gives you an approximation of this number. And x would be the square root of that, which is 95.8, about 96 miles. So this is a rough estimate. So x, this distance, how far is the sailboat from? So how far are we? We are about 95.8, 96 miles. That is the distance. Through what angle should the sailboat turn to correct its course? So we are going this way. So we have to make some adjustment, this angle theta, in order to get to the Key West. So we need to find the angle theta. In order to find angle theta, first we're going to find this angle A, because we can use the cosine law to find A. And after we find A, theta would be 180 minus A. So first we find A, and then we can easily find theta. So again, we're going to use the same formula. And this time, remember, we want this angle A. So everything else is given. What do I mean? All sides, this side is given, this side is given, this side is given. So we can find any of the angles. We have this one, we can find this one. By the way, you can even use the sine law, but we want to stick with the cosine law for the sake of the section. So A squared, opposite this is A, so 150 squared equals the two sides squared, 60 squared plus 95.8 squared minus 2 times this number, and then cosine of the missing angle A. So 150 squared opposite the angle A. The other two sides, one of them is 95.8 squared, one of them is 60 squared, minus 2, multiply the two, cosine A. And again, at this point, you use the calculator. So what happens is we can square this one and this one and subtract from it, multiply this number, you get this one. So cosine A is the ratio of 9684 to minus 11,520. So cosine A is negative 0.8406 and A is 147.2 degrees. It's the cosine inverse. So A is the cosine inverse of this number, 147.2 degrees. So if this is 147.2 degrees, what is the angle we are looking for? 180 minus that, 180 minus that, and that makes it 32.8 degrees. So this angle, which is of interest to us, is 32.8 degrees. How much time has been added to the trip because of this? And we are assuming that we are continuing with 15 miles per hour. We are not changing. So let's see what we have added as far as the distance is concerned. The distance was supposed to be 150, right? But now we covered 60 plus this much, 95.8, 96 miles. So we add these two and we subtract 150 from it. That means we did 6 miles more. And we know that D equals RT, T equals D over R. In this case, the distance, the extra distance is 6 over 15 miles. And that gives us 6 over 15 hours. And of course, that corresponds to 0.4 hours. That corresponds to 24 minutes. Or simply put, you can multiply this one by 60, gives you the number of minutes. Because normally we don't report like 0.4 hours, but or even 6 over 15, you can put it in lowest term as 2 over 5 if you want. But we report it as minutes. That makes more sense. We just did that. Just went over the same thing, class. Here's the next example. Could somebody read this, please?
An airplane flies due north from I don't know what that. Myers to Sarasota, a distance of 150 miles, and then turns through an angle of 50 degrees and flies to Orlando, a distance of 100 miles. How far is it directly from Myers to Orlando?
Perfect, Fort Myers. So let's look at the distance here from Fort Myers to Sarasota is 150 miles. It's a distance of 100 miles. And how far is directly from Fort Myers to Orlando? So we want to find this distance. So if we call this side A, we can try to find this side, and we need, of course, this angle to find it. As you can see, this is given as 50 degrees. This is 180 degrees. And if we call this A, we can find it as 180 minus 50. So let's find side A. Given capital A is 130 degrees. Again, why is that? I want to make sure everybody understands how we arrive at it. This one would be 180 minus 50 degrees. That's how we arrive at it. So we use the cosine law, a squared equals b squared plus c squared minus 2bc cosine a, where a squared is the side we are looking for and it's missing. Then 150 squared plus 100 squared minus 2 times this number, 150 times 100. Cosine A, which is cosine of 130 degrees. And at this point, again, you just have to plug in. I'm going to assume everybody can use a calculator, step by step, and come up with A squared. Then you take a root, and A becomes 227.56 miles, close to 228 miles. That would be the direct distance. Again, the couple of steps using a calculator, just plug in, come up with A squared first, then take a root. First, it gives you A squared, then take a root. What bearing should the pilot use to fly directly from Fort Myers to Orlando? So what bearing? Well, this is angle B, which we don't have yet. So the bearing would be north, B degrees, whatever we find here, going east. So this is B. So that's the answer. So all we have to do, find the missing B degrees. And to find it, you can use the sine law, you can use the cosine law, because we have now all sides and we have the angle A, we can find anything else. Since we are interested in finding angle B, so we are going to use B squared, the opposite side, okay? So B squared, which is 100 squared, equals the other two sides squared, 150 squared, plus this side we just found it to be 227.56 squared, okay? So that means we are looking at A squared plus C squared minus 2AC cosine B. So minus 2 times 150 times 227.56 times cosine B. So this is using the cosine law. And that's good enough. This is the first method. You could use the sine law. Sine of B over 100, the opposite side. And we have this one, sine of 130 over the opposite side, A, which is 227.56, cross product and find it. It doesn't matter which method you use. Again, I'm assuming you can put everything through a calculator, come up with cosine B, and then the inverse function, come up with B. Or you can do the cross product here, come up with sine B, and then sine inverse process will give you the value of B. So I leave it for you to be able to finish and come up with B equals 19.7. Therefore, this is practically given as north 19.7 degrees east. That would be the bearing. All right, class. Here's the last question. Could somebody read this, please?
Flying from Chicago to Louisville, 330 miles, a pilot carelessly took a course that was 10 degrees in error. If the aircraft maintains an average speed of 220 miles per hour, and if the error in direction is discovered after 15 minutes, through what angle should the pilot turn to head towards Louisville?
Perfect. So actually, this is the one before last. I thought it was the last question. In any event, let's see what is given. What is it that we want to find? So first and foremost, this angle is B, and this is what we are looking for. So let's find angle B first, and then we can find what we are looking for, which is simply 180 minus that. So it's very easy to find that after we have that. Here's the distance, we're going to call it C. We've been traveling for 15 minutes. That means 1/4 of an hour, or you can say 15 over 60 times the speed, D equals RT. So the distance here is the speed multiplied by time. The time is 15 minutes or 15 over 60. So to find the distance, here's the time, here's the speed. I'm using the formula D equals RT, where D is the distance, R is the average speed, T is the time, T is 15 over 60, the speed is 220, and we end up with 55 miles. So this distance is given as 55 miles. So we can find just about everything now using the cosine law. We have this side, we have this side, we have the included angle. We can find this side, and we're going to call this A, and therefore A squared is B squared plus C squared minus 2BC cosine A, which means A squared is this side 330 squared plus this side 55 squared minus 2 times the two numbers, and cosine A, which is 10 degrees. It's given as 10 degrees. Again, everything is given. You put this into a calculator, you add them up, and that gives you a squared. So what is a? You take a root of that, and it becomes almost 276 miles. So this distance is 276 miles. So what happens? We have all sides. Everything is given. What are we looking for? The missing angle B. The missing angle B. And again, we want to stick with the cosine law, although at this point you can also use a sine law. You can also use a sine law. Since we want angle B, the opposite side, 330 squared, is equal to one side, 55 squared, plus another side, a 276 squared, minus 2 times the product of the two, and cosine of the included angle B. So 330 squared, the opposite B, angle B. Now pick one of those two sides and square it, and then the next one, and then multiply them and times -2 cosine B. Again, you can find a cosine B from here, and then you can find B by cosine inverse. So using a calculator, there are a couple of steps. Using a calculator here, B becomes 168 degrees. So this is 168 degrees, everybody. What is it that we are looking for? We subtract this from 180. This whole thing is 180. So 180 minus 168 is what we are looking for. So the angle that we are looking for is 12 degrees. 12 degrees. Now, we were doing 220 miles per hour, but now what new average speed is needed to keep the total time of the trip at 90 minutes? Assuming we were planning to make it in 90 minutes, and now we're not going to make it in 90 minutes, how do we change and adjust our speed to still make it in 90 minutes? That's the idea. We've already lost 15 minutes. So first and foremost, what is left? 75 minutes. 90 minus 15 minutes, that means 75 minutes. And we want to go with, since it's miles per hour, the speed, and we want to go with the hour. 75 minutes is 1 hour, 0.25 hours. Because it's 60 plus 15. 15 is 1/4 of an hour, or 0.25. Okay, everybody? So again, 60 plus 15. 15 is 1/4 of an hour. And we know distance is r times t, therefore r is d over t, and the distance is a over t. So the rate or speed we need, distance over time. The distance we are covering is a over t, and a is 276. T is 1.25, and that gives us the speed, which is a little bit more than that. So if we go about 221 miles per hour, 220.8 to be more precise, miles per hour, about 221 miles per hour will fix the problem. And truly, this is the last question, everybody. Last question. Please, somebody read that for us.
A radio tower 500 feet high is located on the side of a hill with an inclination to the horizontal of 5 degrees. How long should two guy wires be if they are to connect to the top of the tower and be secured at 2 points 100 feet directly above and directly below the base of the tower?
Excellent. Thank you so much. So this is 500 feet. we have these two guy wires 100 feet on each side, and the inclination is 5 degrees. We want to know this distance. That means how long this one will be, this distance, how long this one will be. And to do that, first let's make sure we understand what's going on here. Look at this drawing. I want everybody to see. This is 500 feet, everybody. This one and this one we are looking for. One of them we call him X, one of them we call him Y, we don't know. This is 5 degrees. The very first thing I want you to notice is this. If you draw this, if you drop a perpendicular and draw this, this is 5 degrees. Class, if this is 5 degrees, this little one, okay, this little one is this one. This angle is 90 minus 5 or 85 degrees. This is 85 degrees. So that means this angle is 85 degrees. So since this is 85 degrees, so is this one 85 degrees. So one more time. This small angle inclination is 5 degrees. And this is a right triangle. This is 85 degrees if you drop a perpendicular. Since this is 85, this is 85. And this one is 180 minus 85. So I want to make sure everybody understands why this is 95 degrees. Because it's 180 minus 85 degrees. And again, I want to repeat because I want to make sure everybody understands how this thing works. This is X, this is Y, this is 500, this is 100, this is 100. This angle, this small angle is given as 5 degrees. So this angle becomes 90 minus 5 or 85 degrees. And because we have these lines, since this is 85, so is this one. This is a straight line. This is 180 degrees minus 85 is 95 degrees. So I hope everybody can see why this is 85, why this is 95. So in each triangle, for example, this one, let me use a different color actually. If you look at this one, we want to find X. First, we are going to write down A squared is B squared plus C squared minus 2BC cosine A. And this is 85 degrees, and therefore that one is 95 degrees as it was explained. So we're going to use that. So if we look at the triangle on the right, here's the side 100, here's the side 500 feet, here's the included angle 85 degrees. So X is missing. Therefore, X squared is 500 squared plus 100 squared minus 2 times 500 times 100 times cosine of included angle 85 degrees. So I hope you see we are looking at this one. Therefore, using a calculator, you can find X squared, you take a root and it becomes 501.28 feet. Of course, there are a couple of steps missing using a calculator. To find the Y, let me use a different color. Now use this one that is shaded in red. Let's see what's given, everybody. We have this side 100 feet. We have this side 500 feet. We have the included angle 95 degrees. We can find Y. So Y squared is this side squared, which means 500 squared, plus this side squared, 100 squared, minus 2 times 500 times 100, cosine of 95 degrees. And of course, use a calculator again. Find y squared, take a root, and the value of y becomes 518.38 feet. That's how you calculate.